Welcome to all. I am Shivagami from the Department of Computer Science and Application. Today I am going to present a small lecture about an embedded device. So embedded system, each and every day of our life we are using an embedded device. We are just unaware of what are all the device what we are using now. So first let's we move on to the definition of an embedded system. An embedded system is one that has a hardware with a software embedded in it as one of its important components. So in embedded device, the major components are the hardware and the software. So in each and every time, the hardware is combined with the processor in that software only. So it is a special purpose system which is having at least one programmable device, MP and MC. Here MP stands for microprocessor and MC stands for microcontroller, which is used for controlling the specific applications. So what are all the software programs we are creating to manipulate the device as embedded in that particular hardware? Yes, so its software embeds in the ROM, read-only memory, because it doesn't have any specific storage allocation separately. So in the microprocessor or the microcontroller, what is an integrated chip we are using in an embedded device? It consists of all the extra parts what we are using is embedded on that particular chip itself. It doesn't need any extra secondary memories for manipulating this processor. So let me move on to a small example about this. So consider this example, a watch. Each and every day we are tying a watch, but we know that it is an embedded device. So see what is the purpose of a watch? It is just a time display system. What are all the parts in the watch? It consists of an hardware, a needle, battery and a strap. This is the part which is in the watch. Now we are going to the rules. So what does a watch done? That is what are all the process what the watch is doing is prescribed is a software and it is embedded in that chip. So see here, all the needles move clockwise only. In a watch, all the needles will move only in a clockwise direction. A thin needle rotates every second. That is, we know that a second's needle which is moving each and every second. A long needle rotates every minute. So the long needle which is a minute needle, we know that is will move on to each and every minute. A short needle it rotates for an hour. So all the needle returns to the original position after the 12 hours. So these are all the basic rules which is designed only for the watch. So these rules has been decided by the programmer and it is embedded in the software. We can't able to apply these rules to any other device. Yes? So we are moving on to another example. Let me see the washing machine. So what is the washing machine does? It is an automatic cloth washing system. So washing machine is basically used for washing the cloth. So what are all the parts it consists of? It consists of a stated display panel, switches, dials, motors, control unit and inner water level sensor. So see here what is the rules of the washing machine. So it washes by spin, it rinse, it dries, each step displays in the processing stage. In case of any interruption, it executes the remaining step. So this rules is specifically designed only for the washing machine. So as I said earlier, the watch consists of specific rules. Like this, your washing machine, it consists of specific rules. So like this, each and every system is designed with a rule only for that particular system. That is the embedded device. So in embedded device, we are using a processor. So what is a processor? A processor is an embedded system. It is the heart of an embedded system. Without the processor, the embedded system will not work. So an embedded processor is a microprocessor that is used in the embedded system. As it said in the definition, there are two types of processor. One is microprocessor and another one is a microcontroller. What are the essential units? So control unit and execution unit are all the two units that is in the processor. The control unit will fetch the instructions and the execution unit would execute what are all the instructions that fetches from the control unit. Now we are going to move for the comparison of what is a microprocessor and what is a microcontroller. So microprocessor. In microprocessor, a CPU is standalone. we are using an everyday system, we are using a desktop, we see a separate CPU which is standing alone. That is a microprocessor. On that CPU, it consists of a RAM, ROM, an input-output device, a timer, or separate. So we can, if you open our CPU, we can see all these parts separately. But in microcontroller, all the parts will be available in microcontroller also, but the CPU, RAM, ROM, and input-output device and the timer are all combined and presented in a single chip. So it is as I said earlier, it is all the devices are placed separately. It consumes high processing power. But in microcontroller, it requires only a low processing power. So when processing power increases, automatically the power consumption also increases. As the processing power is low in a microcontroller, the power consumption is also low. Here typically the processor will consist of 32 by 64 bits, and there the microcontroller it is 8 by 16 bit. Microprocessor is used for general purpose. If general purpose means we can use anywhere for all the application, it supports the microprocessor. But as I said earlier, microcontroller is only a device which is specifically designed for that particular device only. So it is very single purpose control oriented. So it is very less reliable, that is high reliable. These are all the two, the 8086 and 8085 simulators, and here 8051 simulator has been used. So basically for running a system, running an operation, we need a particular devices. For example, microcomputer, it consists of an input device, output device. So input device, we know that many input devices we are using, and output devices, input output ports, CPU, memory. So these are the very essential parts what is required to run a processor. So each and every part is interconnected and all are combined here, and it is called as a microprocessor. Let's move on to the microcontroller. So in microcontroller, see here, in microcontroller also we have CPU, we have ROM, clock, ADC, DAC, and ROM, and input output device. All these separate parts are combined and integrated into a one chip that is called as a microcontroller. This microcontroller is mainly used in the embedded devices. So each and every part is separately distributed, and here all the parts are combined into the single processor. Next, let's move on to the languages. We all know to run a system, we need a language to communicate with that system. So there are basically two types of languages. One is low level language and another one is high level language. So low level language is used by the machines to understand what are all the instructions given by the user. And high level language is designed for the programmer, where we can able to provide our instruction for our convenience. Here the compiler plays a major role where translating the high level language into the low level languages. So assembly language was the pioneer of a programming embedded system till recently. So currently also they are using assembly language for designing the embedded systems. So nowadays there are many more languages to the program system. Some of the languages are C, C++, Ada, Forth, and Java together with the new enhancement of J2ME. So C, C++, these are all high level languages. We are now using this embedded system for the further developments of the applications. So this recent survey indicates that approximately 45% of embedded software is still being done in a C programming language. So C plays a major role in developing the embedded systems. So not only the C languages also we are using for the development, but C++ is also a get from the base of a C language. So finally we came to the conclusion that a huge number of high quality compilers and debugging tools are available in the C languages by using the embedded systems. So features of an embedded system. What are all the features? Here I am listing 3 features. First one is a single functions. So it executes a single program repeatedly. So an embedded device, as I said, it is a single program purpose. So for example, like we take a TV remote. We are daily using a TV remote. We are switching on the TV, we are switching off, manipulating the channels and varying the channel volume, increase the volumes, everything we are doing in a single remote. But we can't able to take that remote and operate an AC. because the TV remote is designed only for the TV and AC remote is designed for AC. We have a separate remote control to control the AC. So tightly constrained. So next one, it is, as I said, so it is a low power consumption, it is a low cost, at low power, very small and fast, etc. So life threatening. So here life threatening is a major feature of an embedded system, because the life threatening area means wherever the area where the human being can't go inside, wherever the place where the human can go and do a work, this embedded device system is ready to go there and work. Next, 24 by 7 by 365. So this is 24 by 7, we can work that embedded device without any disturbance. Reactive and real time. So it continually reacts to the change in the system's environment, must compute certain results in the real time without a delay. So a best example for this reactive and real time is our air conditioner. So once we switch on the AC, it produces a cooling fresh air. Once it reaches a certain level of sensor, it automatically cut off it, and after whenever the temperature increases, it produces that again a fresh air. So here the basics, the operations which is embedded in the air conditioner is the sensor. So the sensor is an embedded device. So what are all the applications? So household appliances, micro oven, television, DVD player, these are all based on the embedded applications. Next, in integrated systems in aircrafts and missiles, cellular telephones, electric motors and electronic motor controllers, calculators, medical equipments, video games, digital music instruments, etc. So these are all the application area where the embedded device plays a major role. That's all about the embedded system. Thank you all.